Thank you very much and good afternoon. Um, Together with André, we founded a few months ago an organization composed mostly by volunteers called Unispace. It's a division of exponential creativity. What is the scope of Unispace? Is to participate, it's a think tank composed mostly of Europeans, American, Latin Americans, professionals. Most of them from professors at university, some other managers in aerospace or innovation type of organizations. So the scope is to answer to calls from the European commissions and of course ESA, NASA or other type of organization. We have some projects ongoing. We may mention them during the presentation because one of them in particular can be interesting for Mars development. And we are looking forward to continue this type of projects involving Mars, but not only Mars, involving space development. Space development from the first step, how to go from Earth to LEO, and a much ambitious one is how to develop interstellar starship. So we are basically exploring all these possibilities. What we want to talk today mostly is about Mars, but Mars from a different point of view, from the most approaches that has been proposed for Mars. What you're looking for is a holistic approach to space development. We don't believe that we have to choose between going to the moon first, to Mars, to the NEOs. I think the space development is a single goal, it's a single, let's say, mission, and basically we have to develop hardware and we have to develop transportation system and infrastructural system with basically the same components. They can be utilized for most missions. And another important point that we want to stress is the fact that up to now, we are basically discussing how to go to Mars, how can be the first manned mission, how will International Space Agency, mostly NASA, react, are they going to give the budget, are they going to plan it, are they going to prefer some other mission before Mars. We don't believe that any governmental agency will really in a, let's say, reasonable time frame, finance a manned Mars mission. We believe that space activities, and we are seeing already in the last 2 years the first seeds of what we are mentioning, must be developed mostly by private enterprise, and most of them should be business activities, profitable business activities. That's the key, because first of all, the private enterprise approach is a budget type of approach. The cost for a private mission is much reduced than the cost for the same mission which can be proposed by a space agency. And the goals of private missions are more specific. Less wide, but much more specific. So basically, these are our points. Why? A new holistic approach. I mean, the entire space need development. So that's why we are mentioning a master plan where every component must fit from the transportation system, from the infrastructural system, and of course, the several single bodies development. Like we're talking about the moon, we're talking about the asteroids, we're talking about Mars, we're talking about space settlements, we are talking about several components of the master plan for space development. So what we are proposing? We are proposing a standardized and industrialized space transportation and infrastructural system. This space transportation can be utilized for most type of missions. It has to be standardized, meaning that the components must be very few, but standardized. Can be utilized for several missions, can be reutilized. They have to be 100% usable. They have to be simple design, simple utilization. A minimum number of components. It's a modular system. And for long-range mission, we will certainly need artificial gravity. We can't allow humans to stay for months and months in zero gravity for many reasons. We have integrated Moon, Mars, and new mission with the same, basically utilizing the same components. But one of the main sources, in one part of financing, but in the other side also, one of the main motivations for this is an immediate, or as fast as possible, return of investment. Meaning that once we have operational the transportation system, even though it can be an embryonic transportation system, like an Earth Moon, then it has to start producing revenues, because we have a transportation system. And to develop the Moon, to develop Mars, to develop other bodies, there will be hundreds of companies which will need our transportation system and our logistics system. It's like in the Far West. To develop the Far West, they spent, actually it would be billions of today's dollars, to develop the railroads. And what is a railroad? It's a transportation system. Because if you have transportation system, affordable transportation system, then you can really think of develop seriously space. We don't have it now. The goals for Mars are Mars development. The Mars territory is basically the same as all the Earth's surface without the seas. So it's a huge territory with basically limitless resources. We have to create a new high-tech economy, because space can really be not only our next frontier, can really be our limitless frontier. And we are still not developing it. We are still reasoning with mid-20th century mentality. We have to develop a rocket. We're still using basically the same technology. And what we are missing is, yes, we have to go to Mars, we have to go here, we have to go there, but the question is, look what happened to Apollo. What's next? What are we going to do there? So this is the key question. What are we going to do in the new bodies? And this is the reason why we need to develop the motivations for this purpose. So we have to integrate human and robotic manpower. It was mentioned before in other papers. We have to create new wealth opportunities. This goes together with the new economies. We also have to develop advanced technologies. We have to develop local technologies. Martian technology is an entire new field, because we have to build houses on Mars. We have to develop a construction technology on Mars, a construction technology which will use local materials, which will be maybe totally different from ours. We have to develop technology to manufacture LOX fuel on Mars with local materials, and so on. We have to develop technology to process all the minerals which we can find on Mars and transform them in needed materials, building components and so on. We have to develop technology like 3D printing, because if we have a 3D printing technology really working, most of the equipment can be printed on Mars with local material. We can print the rovers or part of the rover. We can print part of the equipment. We can print, and we are proposing, parts of the buildings with 3D printing. So we are trying to face the space development, and Mars development in particular, with a new attitude, a new approach. And the approach is a business-like approach. And of course, one of the final items here is we have to start immediately a local economy. We have a moon economy, we will have a Mars economy. Don't forget that the moon is very rich in helium-3. Helium-3 has a cost of $1 million for an ounce, which means that if you can just get 100 kilos of helium-3 and return them to Earth, you are paying 10 times your moon missions. And also platinum. The moon is very rich in platinum, and platinum can be easily mined in the moon and taken back to Earth, and there is a lot of reduced cost in doing that. So a local economy is the goal, but of course as part of a more global space economy. That's why transportation system, affordable transportation system, and infrastructure, local infrastructure, are the basis of our proposal. Meaning that whatever company will need, let's say, to even NASA have to send an exploring mission, or a company want to exploit or mine helium-3 or platinum or some other, or develop some other type of activity, they will need the transportation, and they will need the facilities, the service in the location. So that's already one return of investment. Okay, now we have divided in general what can be the phases of Mars development. In exploration, the transportation system setup, the infrastructural system setup. Then we are mentioning underground terraforming. What is underground terraforming? Underground terraforming is the way, the most economical, is the most affordable, is the fastest way to allow human to live in a hostile body, can be the moon, can be Mars, can be Titan, can be any of them, by building underground facilities and where they can live in share-sleeve environment, totally safe from the outside hostile atmosphere. This means that Mars, we don't need to, while the end could be the real terraforming, the atmospheric terraforming, in reality we can start immediately to think about, let's say, several colonies with underground terraforming network of urban cells. Then, of course, the technology development, the local technology development, which will create an economy, a local economy which is also integrated with Earth and other space activities. And at the end of several development activities, we can really thinking about Mars to start some terraforming, because we have a planet which is an enormous size and enormous possibility of development. Okay, here, this is a general master plan, let's say, that we are talking about 100 years here. We're talking about the 21st century. As you can see, the first line, we are mentioning the first step of this. We will not go too deep in the first step. We have, which means going from Earth to LEO, access to space. Right now, space accessibility is unaffordable, is uneconomic, and nobody is really motivated to spend such amount of money to develop space activities. Here we are mentioning some technologies. There are more non-conventional, which are not mentioned here, like a Kármán line building, like airship type of launching, and some other. Beam power, and so on. We are not mentioning this here because it may require more than 1 hour and more papers. What we are mentioning is the development of a transportation system and the development of a a local settlement, a Martian settlement, starting from an outpost, going to a settlement, which we call urban cell, which is a self-sufficient habitat where you can have a terminal for either a spaceport or connected with other urban cells. It's like the basic planning unit for a body development. Can be Mars, can be the Moon, can be others. And finally, we have an expansion of the urban cells that can generate bigger cells or a city, or a network of urban cells which are connected by transportation system in the planet. Okay, the enabling technology, we basically mentioned them. We need entirely reusable and affordable two-way air mass transportation system. That's the basic. Entirely reusable and affordable, meaning that we have to use the same components, and they have to be space-based, and they have to be totally utilized. It means a cycling system of transportation between the Earth and Mars. Then we need a Martian habitat system also. They have to be built mostly by utilizing local resources. Then the Martian urban cell that we mentioned as the basic planning unit for mass development. Underground terraforming is the general concept. Then, of course, supporting local technology, develop local equipment with robotic help, transportation system. And finally, developing the Martian technology that would allow a Martian economy. Right now, we are in the very first step. We are exploring. This is curiosity. We are exploring the planet. But we are exploring the planet at a very, very slow rate. I mean, this is because of what we said before. I mean, this is agencies. They have their plans. They want to go at a certain pace. This is not for private ventures. We have another idea. This Airship project, cruiser feeder, we are developing this project under another European Union financing for the Earth. We have the cruiser is a very, very big airship, about 500 meter diameter, which is powered by solar cells, and during the night by hydrogen fuels, which are charged during the day, of course. And the feeder, the cruiser, stays permanently in very low Earth orbit, like 15 kilometers, something like that, in the stratosphere. And while it goes around the Earth, it has the possibility to have the feeders, which are smaller airships, which will bring up and down passengers and cargo. If we take the same concept on a different scale and with different technologies, this is the best way to explore Mars in a much faster possibility, because we can fly at 2, 3, 4 kilometers, fly very slowly, explore the planet, certainly much faster than with a rover. And if we have some particular location that we feel are interesting, we can send the feeder can take samples, take them up, and they can be analyzed and the information sent back to us. So this is another possibility for exploration. Okay, now let's talk about the Earth mass transportation system. As we said, entirely usable, based in space, refuel in space, with LOX produced in, can be manufactured in Mars, in the Moon, in asteroid. Anyway, not on Earth. It must have expansion possibilities. It has to be easy or simple to transfer passengers and cargo from the feeders to the cruiser. Maximum self-sufficiency, a low terrestrial gravity, and this is the point which is most important to make it feasible, is it must become an independent source of profitable business activity. We are talking about a transportation system between the Earth and Mars. which are the components? Very simple. For the transportation system, let's call it cruiser, we have in the upper part, on the left, you have the vehicle cruiser, which is basically an unmanned system with propulsion system, communication system, navigation system, which is attached to a node. The node will allow the connection with the feeders. And the feeders are the real transportation system because they are transferring, in our case, containers from either Mars to the Earth or from one feeder to the other, utilizing the cruiser. Then we have the functional units. The functional units are units that we attach to the cruiser in a scheduled plan. And these units are, for example, the habitats for the crew. Another unit can be a life support system. We can have food production, food manufacturing system, and we can have others. And this functional unit can be built and added with two modules, the ring modules and the spoke modules. What is the ring module? It's a telescoping, you can see it in the bottom, where it's written operational. It's a telescopic connector forming a ring, while the spoke module is the same. It has the ring connector, it's always a telescoping, and another telescoping connector, which is the spoke. And this is connected to the cruiser. We'll see how and we'll see why. Okay, this is just a render of the cruiser concept. Here we have the other components, which are basically the feeder lander, which is an exostructure with a propulsion system and the fuel tanks. And then we have the containers. What is the real scope of the feeder? It's just to transfer the containers from one location to the other. And the containers are standardized. We have a container type A for preparation, like for the first mission, we can have the power, communication, we have a rover, we have a chemical lab, we have some manufacturing equipment for locks, we have a 3D printer for water and so on. Then we have the B. The second mission can be the life support system, which inflatable building system for food, we have water, air, utensils. And finally, the third type is a manned one, where we have a hub, and we have the life support system, and we have a cargo facility. Okay, here we have a terrestrial feeder near the Earth, and it's feeding the cruiser. This is an expanded cruiser. And here, the Martian feeder, basically the same. It's feeding, it's transferring a container to the cruiser. Here we can see it in another view. And here we have the container transfer system. As you can see, the container is transferred from the feeder, is transferred either to a spaceport in Earth's orbit or in another space facility, or it can be transferred from one feeder to the other during the flight, or it can be transferred in a ground spaceport in the moon or on Mars. And here is the configuration of the system. We have the cruiser, we have the feeders with the container, and we are starting to add the hubs, the functional units. As you can see, we have a spoke unit for a hub, and then we can add a life support unit to the system. This will allow us, with the rotation, to have artificial gravity, because this is one of the main conditions. With two launches and with a single system. Okay, the habitat is standardized, has 3 levels. The upper level with the personnel, with the crew cabins. The middle level has all the common facilities, the kitchen, the fitness, the operational. and the lower level has labs, medical center, and other facilities. It's about 550 meters of diameter, and it's about 8 meters high. And here is the concept. We start from Earth. The Earth feeder joins the cruiser, and then the cruiser, from the cruiser, the Martian feeder lands on Mars, and then it goes back. While the cruiser is in a cycling orbit between Earth and Mars. And this is the operational configuration. We start with phase 1, which means it's already manned. Then we start phase 2. We add 2 activities which are critical, and they are, for instance, one is the Spaceport, where the Martian feeder will arrive, and the other can be a return of investment activity, like, for example, debris collection and recycling, or some others. Then we continue adding ring units till we reach phase 4, which is the first ring. At that point, we have what is a conventional space station. In reality, it's not really just a space station. This is, and we will see now on our fast track proposal, how this will work as a Earth to Moon cycling transportation system with possibilities of expansion, and will have immediate return of investment because it will also work as the spaceport for Mars. It will also work, as we said before, for space debris collection and recycling. It can work for other activities. It can work for a retrieval system for asteroids. It can have a lot of activities which will give an immediate return of investment. It can also be utilized to assemble space mission that can be fueled by LOX manufactured on Mars or on the Moon and sent on trans-Mars mission. So it can be a space-based launching base. Here we have a render of how it may look after the first phase, the first one. Of course, this must be expandable, and it is. You can see that it's expandable in a vertical way. We can have the first phase, the first ring, then we can add rings in a parallel way, and it can be powered by a huge parabolic sun photovoltaic antenna. This is similar, but it's not the same concept, that is space settlements. So it can be increased. We can have hundreds of people there because we can increase the rings, not only increase the rings, we can also increase the activities. It can become a hotel, it can become a resort, and it has always some return of investment because number one activity will be transportation, Moon-Earth transportation. Okay, here we think that this can expand from the very first phase. It can be expanded with a retriever system which can be assembled on the operational, in this case on the cruiser, and can capture small asteroid. The one we were mentioning this morning, a little bigger, like about 20 to 30 meters, 100,000 tons. And they can be taken to the facility where their materials can be reutilized, can be processed, and they can manufacture the expansion of the cruiser. So the cruiser will not need anymore to have most components assembled from the Earth with all the cost which it relates, but can be assembled in space with mineral, with local materials. Okay, now this is just to introduce the general concept. Now, how we use this concept? We have the proposal which is called Mars Fast Track, because we can reach Mars without, let's say, hurting the moon development, with only 4 missions. But these 4 missions, actually 3, plus the return will be the number 4. Very similar to Mars Direct or to other proposals. But we have, in the meantime, that the Mars activity is ongoing, we have a moon activity, which is basically to support the Mars activity. So we are going to, a little fast, but I will try to make myself understand. These are the components. You can see we have 3 columns, the Mars, the Moon, and the NEOS. Why? Because these components are good for every kind of mission. So what we need for Mars, 1 cruiser and a node. Then we need the same type of basic unit. At least for Mars, we need the hub and the life support in order to get the artificial gravity. And then we need the feeders. We will need 3 feeders. And then we need the containers. And again, we need the 3 containers. The same thing for the Moon, or for NEOS. We are using the same type of system. So we can standardize them. We can, I'm not saying mass produce them, but we can produce them in a certain quantity. So the economy of scale will lower. The cost of these components is much lower if we build 20 than if we build 1. So this is the entire concept of the fast track. Now, let me describe how it will work. We have to set up a private for-profit organization for Mars development and transform the first manned mission in a step-by-step build-up of Mars development capabilities, meaning that we don't have to send a manned mission and get the man back and then we achieve our goal. We achieve nothing. It's another Apollo. We have to set up, while achieving the first manned mission, an entire reusable transportation system and infrastructure system on Mars. Then something stays. So we know what's next. So we know that we have already something which can continue to function. Set up an entirely reusable and affordable Mars transportation system, and set up an affordable infrastructural system on Mars. And of course, we need a return of investment activities to support and to finance this. The goals basically are the same as the reasons. Provide a safe habitat for humans to live on Mars, maximize the use of local in situ resources, develop a modular construction system, expand the base to a capacity from the first outpost of 4 people, expand to a minimum of 30, which in accordance to our study is an optimal independent station in an extra body. So we have 3 activities: the pre-man, phase 1, pre-man activities, the man arrival in phase 2, and phase 3, the expansion of Mars settlement and activities utilizing 100% local resources, meaning that Mars is already self-sufficient for most activities. Of course, specialized equipment, electrical, electronic, or whatever will come from Earth, but the big bulk of the buildings, of the equipment will be directly manufactured on Mars. And here we have a general schedule. A general schedule of the missions. We have, in the first 12 months, we have a series of Moon missions and 1 Mars mission. Why 1? Because Mars we need 2 years to go and come back. While the Moon we need a week. And we are planning 1 per month on the Moon. Why the Moon? Because the Moon is setting up the conditions for Mars, not from the point of view of technology only, but from the point of view of financing, because we are planning to finance Martian activities, at least in the beginning, with the return of investment of the Earth-Moon transportation system and logistical system. So it will work like this. Fast track. We have the first mission. We are orbiting in a cycling orbit the Mars cruiser, not the Moon, the Mars cruiser. Then the second mission of after the first cycler, let's say, we are sending the first feeder lander to the Moon with the #1 container, meaning all the activities to start preliminary activities on a Moon site. The third one is another lunar development, but we are adding to the cruiser, we are adding the man unit. So we are building up the cruiser components. And at the same time, we are delivering a second feeder to the Moon, and we are getting back the first feeder from the Moon with local material, local minerals. So because it's empty, so we can utilize the container. We don't need to fill it up, but at least we have some feedback from the Moon. And also we have the test that the system is working. So the next one, we will start the Mars mission, because we are equipping with the life support system unit, we are equipping, and you see the #4, we are equipping the cruiser for the Mars. And we are also sending the first Mars feeder with the first container. So this will take 2 years. So this mission will go by its own way. So this is the first Mars mission, which will start basically after the third lunar mission with the same equipment. So the lunar mission is not an end in itself, but is part of the developing of the equipment for Mars. Because to go to Mars, we need to equip it with the man module, for the life support modules, and for other equipment which will be needed on Mars. Now we will continue. And we continue on the Moon. Now, what happened? We don't have any more a cruiser, so we need to send a second cruiser, which will, in this time, will stay on a Earth-Moon cycling orbit. And then we start equipping the cruiser with the same system as on Mars. We're trying to put the hub system, then we put the life support system, and we keep sending feeders to the Moon. The third feeder will be a man feeder for emergencies, a feeder which will be utilized in case the first manned mission to the Moon need to go back to Earth and something doesn't work on their own feeder. And finally, after the Moon is completed, the system, then we are going to send the man to the Moon again, with the same system which we are using on Mars, but on Mars we have 2 years. So in the Moon we have a few months. So we can, let's say, test all the Mars capabilities with the Moon, but not just to test the Mars capability, but to develop the Moon. And at the same time, once we have this in orbit, in the trajectory, we have already the return of investment, because this system can be utilized to sell. To sell what? To sell transportation for companies who want to send missions to the Moon. Okay, at the same time, we have already an operational Earth-Moon transportation system, and we have a second Martian mission. And the second Martian mission will be to send, to complete the assembly of the cruiser with the artificial gravity, and to send 2 feeders to Mars. One is the #2 with the rover, with all the life support system, and the final one is the man system, because for emergencies which can be due to some failure of the man system. And finally, #3 mission to Mars will be the man mission, and is the last one on the right. We have a very short time. I excuse myself because a very short time. We have to explain the. Okay.
Well, thank you. How we are going to go from an outpost to settlement? For this reason, we must to develop a modular construction system that allowed to build standardized units and in an orthogonal form. For example, this is the modular construction system A. Also, we can construct in cylindrical form, for instance, with this is 16 meters in diameter, or in a system smaller than the other, in this case 8 meters in diameter, which can be produced, which can be printed on Mars, or in Neo, or in Moon, or whatever body, celestial body we are going to develop. So this will be our planning components to build our outposts. As we can see, our outposts will have 4 cleared areas: habitat, service module for work, agricultural facility for food production, and a processing facility. These areas will be joined by a connector that also permits the allocation of an airlock for EVAs, extravehicular activities, and the connection with the hub feeder. Well, this is the preliminary configuration of the output. These are views of the model in the different stage of the build-up. The idea is that if we repeat the previous construction systems, the previous construction schemes, we will have at a certain time a settlement much more comfortable and bigger than the initial outpost. Well, as we can see, this is just for dream a little bit. We can imagine at some time building up a Marsville. However, speaking out loud, underground terraforming. However, to maximize the protection of the settlers, we must utilize a new architectural concept. We talk about underground terraforming that was explained before. Also, we have to think about a network of Martian urban cells that contributes with the development of Mars at different locations and possible with different purposes. All of them they should be self-sufficient. And as we saw before with our planning components, we can build clusters, and with those we can build urban cells. And for example, in this picture, as we can see a concentric underground cell. But what is it, a Martian urban cell? The urban cell will be our development goal for the initial base to support the settlement activities, and it represents the basic settlement concept. We can describe underground. Cortamos. Okay. We are going to accelerate. This is the cell. This is our planning component. We have the cell, the connector, and with this, we can build a settlement, an expandable settlement. As the same in urban planning on Earth, the connector that we are going to use must follow a hierarchy, secondary, local for main transportation. Inside the resultant reticula, we can set different forms of expansions. We consider the rhizomatic as the best one because the system allows a maximum expansion in all directions. A basic urban, well, it is to keep up. We have evaluation parameters. Well, this will be the first step. The second step. Okay. Well, this is a configuration where we can see at the above the outpost. The first outpost, and then how it's expanded to a settlement above ground, but underground we have to construct. We have to build our habitats to protect the crew, to protect the settlers from the radiation for the extreme environment. Well, we'll okay. Located in the vicinity of the base and connected with it, this underground facility will allow, we are talking about the spaceport, we allow all our handling and maintenance activities as well as passenger arrival and departure, support the protected facility, will load and unload the shuttle lander, store items to be processed and via terminal. Well, this is a render of the spaceport. The operating system will consist in an inflatable closure, a system we're already in use in our planet. Well, this is the vertical hub with the same. We are going to, well, this configuration, the vertical hub, allows our components, with the exception of the hub, to expand in all directions and dimensions with both cells and clusters. In case of a potential expansion of the hub, a design that leaves excavated volume free of facilities can be considered, but is not included in this design. We are going to accelerate. Okay. We are going to the business plan.
We have a very short time, so I just want to elaborate on this. We built up a profit plan based on the number of missions, and in the upper part we have the cost, and in the lower part we have the revenues. But to make this very simple, this is the break-even plan, meaning that, as you can see, the break-even point is very fast, it's about 4 or 5 years, and the return of investment is much bigger than the cost. So it follows an exponential line, while the costs follow a more direct type of expansion. And what are the activities? There can be construction industry, manufacturing, mineral processing, mining, waste treatment, food production, technology development, transmar mission support, supply space vehicle, prospecting, scientific support, Mars logistics support, and of course, Earth mass transportation. This only for Mars. On top of this, we have the Earth-Moon activity, which are not mentioned here as activities, but only as return of investment. We are also mentioning, and this was proposed 10 years ago in EuroMars conference in Europe, to finance the first manned mission to Mars with a reality show. The idea was taken very lately by Mars One, which we're very proud about it. But we would also use this type of financing system, adding other activities, like a global brainstorming to allow everybody to participate to the mission. So a series of media events, not just one, several media events of various types to allow Earth's population and to raise the audience. But we don't have the time, unfortunately. And here, the last proposal is to...
Well, speaking about the media event, this media event must to be filmed in a simulated base where we are proposing a 3D printed base in the Andes. Well, through the years, different location has been defined for Mars analog uses. And for instance, we can see the following. However, only the flashline, the Mars Desert, Nemo, High Seas, the Svalbard, and Concordia station are operatives. And as you can see, in South America, we do not have yet. We don't have one yet. South America, where the most specific in the southern Andes region, we have excellent places for such a facility. Certainly in this region we can find some of the most important international assets like La Silla, Paranal, Alma, Airship observatories, among others. Also this location can be used for instance, for Viking 1 and 2 and the Phoenix Smart Launchers and different models of spacesuits for testing sites. Well, speaking about more specifically of the Atacama Desert and the nearest region, the Andean Plateau, the Atacama Desert, mostly in Chile and Peru, is shared by the two countries. It's the oldest desert in the world, geologically speaking. Also, this is the driest place that we can find. Indeed, there are specific locations where has not received any rain in centuries. Thus, we have there an extreme hyperaridity. Full solar radiation due to high altitude that range from 3,000 and to 6,000 meters above sea level. Also we have an extreme temperature amplitude, and this is the one of the most isolated place on Earth, with the exception of Antarctica and the Arctic, of course. Which will be the main goals? In the Atacama Desert and its vicinity are the birthplace, in our opinion, for a new Mars analogs research station. However, we are considering that this facility should be built following a new approach, a new strategy. It should be a 3D printed modular habitat base. It won't be easy. We have to proceed several stages, but this could be this is a preliminary phase. One important to say that in the third stage, we can have a research station like the flash line to set the outpost and then to construct the 3D printed habitat base. To conclude it, this is a render of the possible habitat in the Atacama or Mars. And then we are going about to the motivation of this.
Well, we just basically say conclusion. What we want to stress is that we believe that if we can standardize all the components and we can reason on a business-like way to approach space mission, including Mars mission, we may have much more chances of achieving that sooner than with traditional agency finance missions. So this is why we are trying to send the message that this system, a more manufacturing type system and a more business-like motivation should be at the basic of future space development. Thank you very much.
I'm a great believer in Murphy. And Murphy says that if you have two or more things, you need to have multiple ways to get around the ring or back and forth. And almost none of your layouts do that. You need to get more redundancy locally in the layout that you're presenting to people in these presentations. And they'll make more sense to people who believe in Murphy. Murphy's Law is an understatement.
Murphy Law will always be around, but actually been around 60 years because we are still at Apollo. We didn't do any progress. This is a proposal. It's subject to all the comments like yours, which are welcome. And of course, the redundancy, we have one emergency system. Maybe we may need more, but we need to start doing something.
I understood the economic analysis that you put up there really quickly. It looked like after
5 years?
Yes.
How is it possible, and why are you doing it now, 10 years from 5 years?
Because what will generate profit is not the Mars in the beginning, will be the Moon. And the Moon system will generate profit after the first year, because after the first year, the Moon system will be operational, both the transportation and the logistic. We just figure out 200 million per mission, I mean, for sales, which is reasonable to go to the Moon and send a mission. Of course, if you have a small mission, a small package, you will add up, and each mission can be worth 200 million sales, which is nothing compared to what the Russians are charging to send a mission to the ISS. So it all depends, of course, of one basic condition, general condition, that there is space development. And who will pay for this mission? Companies that will come out, like somebody who wants to exploit, to mine helium-3, or who wants to mine platinum, or who wants to, or scientific labs who want to put an astronomical station on the Moon or some other. I mean, the point here is we must motivate, and to motivate we must give affordable transportation and logistics, because if you send somebody there and you need a rover to take your equipment to 50 miles, you have it. It's like a hotel. You have all the logistic facility, you have the food, you have the habitat, and of course you have the water, the life support and everything. So this is the concept. The money will come from selling services, not by going there and say, hey, this is my flag, but by selling services to companies who will want to develop space. This is the basic concept.